program memory consideration. So, how your program memory addressing the program memory is addressed using the CPU that is given here. Here, each member of the PIC family of microcontroller included in this text has either 2K size or 4K size of addresses of program memory. So your program memory size will be either 2K or 4K. 2K na 2048, 4K na 4096. Okay. So a program memory of 2K addresses needs only an 11-bit program counter. So I think you all know what is program counter. Program counter is nothing but it will be used. This is a storage device or register which will be holding the current address of your memory. Okay, which your CPU accessing. That will be holded by your program memory. Sorry, program counter register. Okay, so that program counter register capability will be only 11 bit is enough for accessing the 2K memory size of program memory. Okay, see here, a program memory of 2K addresses needs only an 11-bit program counter to access any address. So 2 into 11 will give 2048, that is nothing but 2K. Okay, so 11 bit is enough. 2 power 11, this is 2 power 11, 2 into 2 power 11. So 11 bit is enough for the program counter register size. Okay, so a program memory of 4K addresses means that is program memory with the 4K size now it need only 12-bit program counter. Okay, so 2 power 12 will give 4096. Okay, in this manner you can calculate the size of your program counter. Okay, so this PIC family actually uses a 13-bit program counter. So maximum all the PIC families will be using program counter size as 13 bit. Okay, so 13 bit now what will happen? That is 8K. Okay, see here 8K. 8K program memory is used to in every PIC families of microcontroller. So this PIC family actually uses a 13-bit program counter allowing for extending the family to an 8K. மேம் எப்படி 8K கரெக்டாக சொன்னீங்கன்னா சி ஹியர் 2K 4K அப்படி டபுள் 2 இன்ட்டு 2 4 4 இன்ட்டு 2 8 அதே மாதிரி அடுத்தது 16 அடுத்தது 32 அடுத்தது 64 in this manner it will be converted. Okay, without changing the CPU architecture you will be changing the program memory size alone. Okay, so for the 4K and 2K parts the upper bits are simply ignored during the fetches from program memory. So two addresses in the program memory address space are treated in a special way by the CPU. When the CPU starts up, two addresses are nothing but starting address as well as the interrupt signal address. Okay, these are the two signals which will be used by program memory in the special way. Okay, so when the CPU starts up from its reset state, its program counter is automatically cleared to 0. Okay, when your CPU starting, the program counter automatically clears up to 0. This is shown in figure with the content of address H000. H is nothing but it represents the hexadecimal value. So 000 value of your address. Okay, address value which is stored in the program counter at the time of CPU starts. Okay, being a go to mainline instruction, the second special address that is H004, this will be used for interrupt. Okay, so 004 will be automatically loaded in the program counter when an interrupt occurs. So interrupt means go to interrupt service instruction execute ஆகிறப்ப automatically your program counter will be loading this address 004. அதே மாதிரி go to mainline instruction execute ஆகிறப்ப automatically your program counter will load the 000 address. Okay, So a go to interrupt service instruction can be assigned to this address to cause the CPU to jump to the beginning of the interrupt service routine located elsewhere in the memory space. So automatically your program counter load 004 address in the program counter. So program counter will point out the current address of the memory to execute. So automatically what will happen, it will be jumped to the current address which is owned by your program counter in the memory, okay, by the CPU. As will be seen in chapter, when we deal with the tables, the program code can be simplified somewhat. It any tables that are created or assigned to address in the range H0052 0FF. So in the chapter 3 means this is a book, so which will be giving the table for assigning the address for some works. Okay, it is given in the chapter 3, that is given here. For most application, these 250 locations provide more than enough room. So for many of the application, this 250 memory address space is enough to do any process. Okay. So the mainline program begin immediately following the table. A microcontroller mainline program typically has the structure. So this is the structure of the mainline program. So mainline call initial means you will be initiating the program. Then main loop, you will be calling the task 1, task 2, and then loop time will be ending. That is calling instruction will be ending, and then automatically it will be going to the main loop to repeat the same process. Okay, this is the structure of your mainline program. This pipelining technique already shown to you. This also pipelining technique for the subroutine program. So next we are going to see about the fixed timer. Okay, so far we have seen about the program memory and how the address memory, memory addresses are accessed from the program memory, and everything is seen there. Now we are going to see about the timer, which will be used to make the time it takes to transverse main loop a fixed amount of time. So timer is used for maintaining the time, okay, for executing the every instruction or task. Okay, so the timer will be dedicated to this purpose and will obtain a loop time of exactly 10 millisecond. So the loop time of uh, instruction or main program to execute will be considered as a 10 millisecond if task 1 is supposed to toggle an LED indicator lamp every half second. So in every half second you have to toggle the LED indicator. Toggle means what? On off, off on, on off. இது மாதிரி மாறி 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 you have to indicate your LED in for every half second. So this is the task 1. Okay, so for this your timer, how it will be fixing the time is given here. So then it need only increment a scale of 50 counter. So 50 counter is needed for making the indicator, that is LED indicator lamp, to on and off for every half second. Okay, so 50 counter means 500 by 10 na 50. Okay, so this much of cycle is enough for making the lamp to on and off. Okay, so the LED is then toggled once for each complete cycle of this counter means. So you will be having one cycle now, or complete cycle la half will be taken for the on and off conditions. Okay, first half your LED lamp will be on, the next half of the cycle your LED lamp will be off. Okay, so in the complete cycle, one cycle, your LED will be toggled means on and off. Okay, this is program counter in accessing program memory. So this is the thing they are given here. இங்கே நம்ம பார்த்தோம் இல்லையா, how the program memory is accessed for 4K 2K and 8K memory size of program memory. அதுதான் இங்கே டயக்ராமில் ரெப்ரசன்ட் பண்ணியிருக்கான். see here program memory access for pic parts having 2K size of program memoryக்கு எவ்வளோ பிட்ஸ் ப்ரோக்ராம் கவுண்டர் தேவைப்படும். ஓகே, ஸோ யூ நீட் ஒன்லி 11 பிட்ஸ், 1 2 3 4 5 6 7 8 9 10 11. So another 2 will be ignored for the 2K memory size, program memory size. For 4K it will be needed 12 bit size of program counter. So one bit will be ignored because here in the pic memory will be having 13-bit program counter. Okay, so 4K size ku 12 bit is enough. If you are going to use 8K bit means only 8K size of program memory means only you will be using all the 13-bit program counter. Okay, the next program memory map. So for that they are giving the explanation in before itself. So the mainline program begins execution when the pick comes out of reset. Okay, so every mainline program will be beginning by resetting your device. Okay, so on resetting your device, everything will be starting from new. Okay, new addresses. Okay, it continues running until one of the picks interrupt source request service. So the mainline program will be running till any of the disturbance, that is any of the interrupt request received from the other parts of the device or other external devices, till that your main program will be running automatically. Okay, so at the time of at the point of execution of mainline code is temporarily suspended. That means when you are acquiring the interrupt service from the external device, what will happen, the main program will be stopped temporarily to run. Okay, so it will start to execute the interrupt which it give requested for the service. Okay, for temporary case, and then it will be 1 minute. யாருடா? ஹலோ ஹலோ. சார் சார் சொல்லுங்க சார், தம்பி அட்டன் பண்ணிட்டான். ஆ சரிங்க சார். இதோட கட் பண்ணிடணுமா? சரிங்க சார். ஓகே 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 சார், ஓகே சார். ம், சரிங்க சார், தேங்க்யூ சார். சார் இன்னைக்கு அரேஞ்ச் என்னங்க சார்? சரிங்க சார். சார் இன்னைக்கு அரேஞ்ச் பண்ணது யாரு, எந்த ஃபேக்கல்ட்டி? எம்சி சாரா? இல்லை சார், அந்த சைக்கிள் வர்றதுக்கு தான் நான் கேட்குறேன். அதுக்குள்ள நான் 1 வீக் பிஃபோரே நான் ரெடி பண்ணிக்கணும்ல, அதுக்காக தான் கேட்டேன். ஐயோ, நெக்ஸ்ட் வீக்கே வருதா சைக்கிள்? ஓகே 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 சார், ஓகே சார். ம்,
முடிஞ்சிச்சுல, இனிமே அவ்வளோதானே,
ம்,
நிறுத்தா,
ம்.
அவ்வளோதானே.
இருக்கு, இன்னும் முடியல. நான் ஃபோன் வரவும் கட் பண்ணிட்டு பேசிட்டு இருக்கேன்.
இல்லை, இதோட சரிதானே.
இன்னொரு கிளாஸ் இருக்கு 2:30க்கு. இந்த இவனை புடி வந்துடுறேன்.
அதான் முடிய போகிறேன்.